Thank you. So imagine that you can spend your days looking at the stars and seeing such fascinating shapes. Well, as you already heard, I started my career working with the infinity of space and handling the enormous amount of data that it produces. But although I graduated as an astronomer, I switched to a career as a data scientist. But I guess I couldn't say goodbye to the visually focused astronomer inside of me because I found myself loving the visualization of the data even more than the analysis itself. So I switched gears again, and then now a down-to-earth data visualization designer working under the name of Visual Cinnamon because whoever can spell my name correctly anyway. And I've found that in data visualization, I tend to be a perfectionist. I love spending hours and hours on some small detail to make it exactly as I have in mind. And being born and raised in Holland, I always willfully hope that maybe my craving for perfectionism stems from the same genes as those of the Dutch master painters of old, who managed to put such a dedication to detail into their artworks. I mean, it's a really small country, right? Could happen. And although painting and data visualization aren't exactly the same thing, I do always start my visualizations on plain paper. And once I have like a mental image of how something should look, the computer had damn well be able to create some semblance of it on the screen for me. However, usually what I have in mind isn't quite the default setting or what all of the examples are using. And that forces me to try and think outside of the box from time to time to try and recreate my concept. But you'd be surprised by the results if you try to experiment with the norm or use things in an unconventional manner or be inspired by different fields of design to create a more effective or fun visualization. Okay, so we're almost ready to take off and go beyond the shapes, but first, let me explain to you how SVGs, Scalable Vector Graphics, fit into the world of D3, which is a JavaScript library that has become the standard in online data visualization. And you might be using something else like raw or plotly or high charts. Chances are that under the hood, they are all using D3. And I'm using D3 for all the examples to come as well, by the way. So once you start working with D3, you realize really quickly on that its basic building blocks, its elements are SVGs. So you're bringing these SVG circles and lines and rectangles and texts and paths together to create awesome visualizations. And I'd like to take you along on my journey on how I started using SVGs beyond their mere shapes. So my first step beyond the shapes came when I was trying to create a color legend. I wanted something that would go smoothly through all of the colors that I was using, and that's how I got into SVG gradients. See, it wasn't really necessary to read off the exact value that each color represented. It was more about seeing trends and patterns, like in a heat map, for example. So this one shows you the number of traffic accidents that occurred in the Netherlands during a full year, aggregated by day of the week on the rows, and then hour of the day on the columns. And the darker the color, the more accidents that occurred. So no surprise that the morning and especially the evening rush hour see most accidents. And it's not really important that you see if it's 1,440 or 1,520 accidents. And the legend below is what I mean with having this smooth color legend. And it's nothing more than a simple SVG rectangle filled with a gradient. And because I'll be using a few more gradient examples, I'm going to show you how we can create a linear gradient in SVG, but based in the code of D3. So it's not an introduction to D3, but I hope that the code will be straightforward enough for you to get the gist of it and to see eventually how useful it is to use D3 when you want to work with data in the browser. So in SVG, there exists a linear gradient element. And you need to nest that within a defs element. And defs is short for definitions, and it holds special things such as gradients and filters. You need to give it some unique ID so you can reference it again later on. And then you set the direction along which you want this gradient to run along your shape. And you do that in a way that's very similar to just an SVG line using x's and y's. So we can set the starting position with the x1 and y1 and the end position with the x2 and y2. And we can do that either in percentages or in exact pixel locations, but usually percentages is easier. So here, if you want to make a horizontal gradient, we set x1 at 0%, x2 at 100%, and then both y's can be the same, so 0 is fine. And by playing around with these numbers, we can either make that a vertical gradient or a gradient along any angle that you want. Although what I'm showing you here is not true, because it's really the bounding box, so the smallest rectangle that encloses the entire shape, that defines where these start and end points lie. So in this case, the 0, 0 starting point really lies outside of the visible shape. And that means that once the color comes into the shape, it's already turned slightly more purple. And maybe you don't want that. That's fine. You don't have to start at 0 or end at 100. But just know that the area outside of your directional arrow will be padded by default with whatever color is present on the outsides. But we are going to use just a normal, straightforward, horizontal gradient all the way from the start to all the way up to the end. Well, after having set the direction, all that's left to do is supply it with some color information. And for this, the stop elements exist. So you supply the stop element with a stop color and an offset, which is the location along that directional arrow where this color should be pure. So here I've appended sort of a lightish blue color at 0%, and then I'm going to append one more because otherwise it wouldn't be much of a gradient. At the other end, at 100%, that's a little bit more dark blue. Another gradient is ready to be used. So we select our rectangle and we set the fill style by referencing that unique gradient that we had before. Well, appending these stop elements can be quite tedious if you have a lot of colors in your gradient. And this is where D3's data step really comes in handy. So we go back to that linear gradient after setting its horizontal direction. But now I will append a data set containing all of the offsets and colors. And then using D3's data step, it will actually create a stop element for each of my data points. And it will append the data to each of those stop elements at the same time. So it only takes me 2 more lines to set the offset and the stop color for each of the stops. So that's really where the magic of D3 comes from, being able to connect data to elements in your DOM and then being able to style those elements based on your data. And if your colors are sort of evenly spread out throughout throughout the gradient, you can make it even shorter by just supplying it with an array of colors, because then you can calculate the offset location by using the index in the array. So that makes it a lot faster to even make these sort of complex gradients. Well, here is another example of something that is in essence a heat map and can thus be combined with a smooth color legend. And this is the visual output of a machine learning technique used to cluster data called self-organizing maps. And it is what started my love for hexagons. And I wish I could tell you that I was using the color palette that is visible right now, but I was using this technique before I really got into data viz, and I do come from a science background, so my go-to color palette was naturally a rainbow, which I have since then learned is very much a no-no in data visualization when working with continuous color scales, so something that runs from like 0 to 100. And also, some small thing is that in D3 you can easily animate things. So I can make something like this, but yeah, you know how to do that with front-end things as well. But it's amazing how clients can just be mesmerized by like the smallest of animation. It would make their eyes like pop and like, oh my god, I need this as well. It's so crazy. Well, staying in the rainbow mood one slide longer, here's one of my favorite temperature visualizations. This one shows you the minimum temperature to the maximum temperature of each day, and then in each of these bars is colored according to the average temperature of that day. And here again, it's not really about seeing the exact temperature that it was on each day. It's more about seeing like the trends. When was it really hot and when was it really cold? And I'm going to try and explain why rainbows is not a good thing to use for these continuous scales. So for one, the biggest problem is that color isn't equal to us. We see many shades of blue and red, but yellow is really narrow to us, but it's a completely different shade to us than either red or orange or green. That means that if we go from like this yellow over here that might be like 12 degrees, and we go like 5 degrees up, we are already somewhere in a bright or dark orange. Whereas if we go over here like 25 degrees and we go up to 30, that's going from a dark red to an even darker red. So for us, that second step, even though it was also 5 degrees, is not visually as intense as the other step. So that's why rainbows are not good to use. And I'm trying to sort of, please don't use them anymore, except for like categories like countries or stuff. So being an astronomer, I also wanted to make a visualization about exoplanets, which are planets that rotate around stars outside of our solar system. And I wanted to do some sort of data storytelling where I would explain how weird and wonderful these planets really are. And to make all of these planets rotating around one generic star, look a little bit more than, well, just flat circles, I turned them into tiny spheres by using a radial gradient, which is the second option that you have besides a linear one. And I also wanted to make each of these gradients, each of these planets, colored very specifically to the planet's data. So each one of these planets got its own radial gradient. And that's something that's, again, very easy to do with D3's data step. So instead of now making these stop elements, we are now creating a radial gradient for each of our data points. So after appending this, we still need to give each of your radial gradients a unique ID. And now this data is appended to the radial gradient. So we can actually set something like the base color, a stop color, that's based on a feature of your planet. And then by using that, we can either make it a little bit lighter on the inside, darker on the outside, move that center location a bit, and then increase the directional arrow. And now we have something that sort of mimics a 3D sphere. And if you were to look in your DevTools, you'd see that you have a whole bunch of radial gradients, and each of them would be slightly different. Well, afterwards, we select our planets, our circles, and we can set the fill style. Well, instead of showing you a visualization about exoplanets, of which many have been made already, I thought I'd take the opportunity to show you what I think is one of the most important visualizations from astronomy. So this is called a Hertzsprung-Russell diagram. It is not the actual one, it's a recreation. But what you see here are no longer planets, they are stars. Some of our nearest stars, by the way. So that's Betelgeuse, and there we have Rigel. And on the vertical scale, we have luminosity going upward, and it's a log scale, so that's quite intense. And on the horizontal scale, there's temperature, but note how the hotter stars are on the left and the cooler are on the right. That's due to historical reasons. And why I like this visualization so much is because it's basically stellar evolution in a chart. Things have been discovered from this chart before they were even seen. People have understood things by looking at this chart, understanding this chart, and then figuring out the physics that goes on behind it. It's like, at some point, there's a part over here where you get stars that are physically unstable, so they pulsate, and they would find stars that would pulsate in that area. They can find a whole group of stars that was all born around the same time, and if you were to plot them in this chart, they would go around this line, which is called the main sequence. It's where stars usually spend 90% of their time. And by seeing where stars start going off of this line, you can say how old that bunch of stars is. I mean, just by plotting it on a map. I think that's pretty cool. So, favorite chart. Our sun is over in that bunch over there. It's been there for 4 billion years. It'll stay there for 4 more before moving off. And these stars in the upper section, they are indeed a little bigger, but this is not quite the right radius, because this is how it would actually look. But that doesn't really make, can you imagine that? Doesn't really make for a very readable plot, so that's why we have to do something else with the radius scaling. Also, stars are things that shine, they aren't shine upon. So by tweaking that radial gradient a bit, we can make them look a little bit more like the glowing orbs that they really are. Another reason why I like this plot is that stars, they are round, and they are shining to us in these colors. So it's like you're basically almost doing no visual encoding. It's like you're plotting the things themselves. So personally, I don't know of a better subject to use for scatter plots than stars, but I might be biased. Well, besides using data to set the colors of your gradient, you can use it for any aspect of your gradient, such as the directions. And having seen one of the older Avenger movies, not the newest, although I have seen one of them, I was interested to know how often had these Avengers appeared in the same movie together. And so I used this sort of chord diagram, and then these inner chords, the thicker one of these chords, the more movies these people have appeared in a movie together. And typically these chords are filled with one color. But in this case, that didn't really make that much sense because the directions, the connections are symmetrical. Since if Thor appeared in a movie together with Hawkeye, then the reverse is true as well. So I wanted to do something else with these colors. I could have turned them all gray, that's totally boring. So I wanted to instead fill them with gradients. So let me explain. We focus on Black Widow here. So I wanted to fill these 5 chords with a gradient running from the color of one Avenger to the color of the Avenger at the other side along these directional arrows. And then something like this, but then inside of the chords. Well, one of the other nice things that D3 does for you is that you can supply a data set to some of the functions of D3, and it will then transform that into whatever you need to make that particular chart. It could either be SVG shapes, it could be angles or widths, whatever you need. And in this case, I can supply my Avengers data set, and it will turn that into an array that contains everything that I need to draw these inner chords. And we usually call that chord.chords. So this time I want to make a linear gradient for each of the chords, so this time I apply the chord.chords dataset to D3's data step so that we get one for each. Still need that unique ID because now we make it depend on the source Avenger and the target Avenger. And one thing that I wanted to point out is that in this case it's actually easier to not use the bounding box of the chords or the object itself to set the direction, but to use the coordinate system that you have in place where the origin is in the center of the circle. And you can do that by setting gradient units to user space unused. The reason is that in this particular case, it's easier to find the exact pixel locations of those two colored circles than it is to set these percentages. By using the variables that are available in the chords dataset, which I've shown here with sort of the smaller gray circles, the inner radius and some sines and cosines. So that formula may seem scary, but it's actually not. It's just like the difference, so you get the halfway between, then you add it up so that you get the full angle, then you subtract half because there's something weird between, never mind. I have a blog about it that explains each step. So after having set these directions, all you have left to do is append two color stubs. One at 0% that's colored according to the Avenger at the source, and another one at 100% that's colored according to the Avenger at the other end. And then with these changes, this is the result, which I feel now is a much better representation of both the Avengers that each of these chords links. But we don't even have to use gradients as something that runs smoothly from one color to another. They can be very handy for abrupt color changes as well. So many very fascinating analyses of baby names have been done in the past, such as the most trendy and poisoned and unisex name. Did you know, for example, that before the 1990s, Ariel was a very unisex name? But that stopped pretty quickly when Disney decided it was a girl name. And then I was surprised that the data actually goes back to 1880. However, a typical screen isn't wide enough to do justice to 135 plus years of volatile change. So I use this technique of focusing context, where there is a small chart below that shows you all of your data, from which you can select a window that shows you sort of that part in a large chart above. And the user can move this around, and you give kind of freedom to the user to look at whatever they want. It's funny how in the olden days there was like not that much change, and now it's like total chaos. So what you see here is each of these lines is a name. And then it goes from the vertical is like to position in the top 10, and on the horizontal scale we have the years. So for example, in 1987, Jessica was the most popular girl name in the US. After that we have Ashley, Amanda, Sarah, and so on. The color is a representation of the starting letter of a name, and then the thicker a line, the higher the position it reached ever. So we can see, for example, that Emily was number 1 once, but here Megan never got above number 10, although trying a few times. And it's quite funny how in the Netherlands, it's actually interesting how the first 100 years, it's just Maria. Maria is the most popular girl name. Then it drops into nothingness in 10 years, and now it's even more chaotic than this one for the US. It goes all over the place. Anyway, so to make this connection between this window and the bigger chart more clear, I wanted to color this smaller window exactly the same as the big one, but only within the selected portion, and then make it gray on the outsides. However, you can only stroke a line with one color. And I didn't want to have to split this up into 3 line sections, like one before, one within, and one after, and then update that dynamically. So I used like these abrupt gradients instead. And what you do is really simple. You basically append a color stop again. You've set your gradient, and I'm going to append a gray stop at 40%. Well, there's only one color, so everything's gray. I append some other color at exactly 40% as well. And now it makes an abrupt stop. That's basically it. And because of this padding, like everything outside of your directional arrow will be filled with the color that's on the outsides, you get this effect. Well, to create this window, I do the same, but in reverse order. So at, like, say, 60%, I append a colored stop first, and then a gray stop, and then I get this window. If I were to, for example, draw a rectangle and take one of the gradients of these lines, it seems as if I have 3 rectangles, but it's really just one with a gradient. And if I want to make this interactive and updated, I need to give these sort of left 2 color stops some unique class, such as left, and then I need to give the other 2 colored stops at 60% some other unique class, such as right. And then there is an event for this window that's called the brush, which means that you move it, and then if you can select, you sort of have to recalculate where the percentage should be, and then select both either the left or the right, or either or both. And then it seems as if this gradient is just updating right along with that window that you have available. So abrupt color gradients can also be really useful for showing categories. So here we have a chart that shows the changes in the mean body mass index for a whole bunch of countries over the last 40 plus years. And although not so abrupt in real life, according to health standards, you are overweight when your BMI is above 25 and obese when it is above 30. And typically when I see this done, I see that people have put like colored rectangles behind these sections in the chart to highlight these categories. But I wanted something that was less intrusive. So instead I created a gradient and filled the lines with that gradient. And now when I hover over one of these, it makes it, I guess you can still pretty easily see where a country went from still being kind of healthy to going into the unhealthy part. And it doesn't matter if something changes, the gradient's kind of fixed in place. So even if I go from men to women, the data kind of moves right along that background gradient. I was also pleasantly surprised when I found out that gradients can easily be animated. And while working on a fun project, I had access to a data set that contained what education people had done and then what occupation they ended up doing a year and a half after their graduation here in the Netherlands. And we wanted to visualize these flows from education to occupation. And I could have used a Sankey diagram, which is really good at showing flows. But the final result was going to be used in the media, and I do love my circular charts. So I wanted to create more of a circular version of this, which did not exist. So actually I went to a chord diagram, which is the thing that we saw with the Avengers example. And then with some sort of creative use of the options and some hacking, I kind of turned it into a circular Sankey. I wrote a blog about how to recreate this. I called it the stretched chord diagram because I am really bad with names. And then thankfully people on Twitter started calling it the bat plot. So you can create your bat plot. Well, here is the actual final example, where education's on the left and occupation's on the right. But to make this flow from left to right a little bit more obvious, I filled the chords with an animated gradient. I made it really subtle though. Here it's kind of apparent because so many screens, and I never know for sure at the start, lots of screens are not doing any justice to grayscales. So it was more subtle than this. It's like you could see it, but not quite as this. And animating a gradient is really easy. There is one thing that we need to set differently at the start, and that is the spread method, which is normally set to pad, like I've said a few times, but now we need to set that to reflect, so that it creates mirrored-like copies of your gradient outside of your directional arrow. And then we kind of need to move that directional arrow across the shape. So we animate the x1 attribute from 0 to 100% over 7 seconds, and we do that indefinitely. Then we get this rather psychedelic result because the end of the directional arrow stays in place. So we also animate that one, and then from 100 to 200% because that will always keep 100% difference. And now it seems like as if we have like an endless moving linear gradient. Well, animating a gradient also gave me an excuse to put one of the most famous within the data viz world visualizations in my presentation. So this is a recreation of Menards Map of Napoleon's. It's from 1896, the original. And this one shows the march of Napoleon's army towards Moscow and back again in 1812. And the brown stroke is sort of the path that the army took towards Moscow, past cities and rivers, and black is back again. And then the line chart below is for the march back when the temperatures got really low. So it's kind of showing you an idea of like maybe some of the men also passed away due to this extreme weather. And then to make it a little bit more clear that brown is towards Moscow and black is back again, from like when you see it first time, is to have this sort of slight animated gradient inside of it. The thickness of the line is the number of troops that was still alive at that point in time. And it is heart-wrenching to see that out of the 422,000 men that started this campaign, only 10,000 made it back alive. So he made this visualization as sort of like an anti-war attempt to show that it was futile. Okay, so we're finally leaving the realm of SVG gradients and going into SVG filters. But to be honest, we're also kind of leaving the realm of effectiveness in the visualization behind a bit and going a little bit more into towards having or creating a bit of fun in your visuals. So setting up a filter is very similar to a gradient. This time we append a filter element and still give it some unique ID. After that comes the magic part, where a specific combination of filters might create something that you would have never expected. But I'm not going to show you any code in the slides to come, because it's always the same bunch of code. If you want to apply this specific effect, you need to apply that bunch of code and maybe change some numbers. So I always reuse snippets from older works or older apps or demos, and then kind of tweak the numbers. Although they will be in the blogs, which I'll put in the end. But anyway, once you've created your filter, you select the element that you want to apply it to, and now you set the filter style, not the fill one, by referencing the ID. So the first one is rather subtle, but can have a nice added effect in the right circumstances. So some people love rated charts and other people hate them. I'm not part of that latter group, so at some point I made a redesign of a rated chart in D3. And I was fine with it like this, but then I remembered coming across some snippet of code about a SVG text drop shadow or glow, and I thought, well, maybe that will make this look more interesting as well. So I'll show you the glow. It's very subtle. That was it. And it also really depends on personal style whether you think this is an improvement at all. But what happens is really simple. You have your element, and then the filter creates a blurred version. It pastes the original one back on top of it to give the appearance of a glow. And you can apply this to SVG rectangles and paths and circles. And I've used it a few times in subtle ways in my visuals to kind of make something a little bit more pop. For example, with spirographs, which I used to love as a kid, and I love it even more on the browser because it's not like halfway through. I kind of fuck it all up. I'm not sure if I could say that word. But here that doesn't happen. And by making it sort of glow, I feel a little bit more neon and lifted off the page a bit. So another filter that has a subtle but interesting effect has to do with motion blur. So the faster to us and closer to us things move, the more blurred they appear. And with the right filter, we can make that appear on the screen as well. For example, these circles, the faster they move, the more blurred I make them to give the appearance of fast movement. And I first saw this happening when I saw sort of like images being blurred across the screen in an image gallery. And I thought, well, data visualization also often shows movement, so I wanted to see what I could do with that. And this filter is actually even kind of more simple than the one before. You really only blur the object, but in one direction, and you blur it a lot more. And I feel like it makes things just a little bit more natural. So here's no blur, here is with the blur, no blur, with the blur. I preferred the blurry ones. Thinking of data visualization, I thought, well, wouldn't it be appropriate to make one about the top running speeds of a bunch of animals, and maybe at one point the fastest human. I'm not totally sure if he still is though, but he's the one that's most in my mind. So when I will move these circles outward to their speeds, they will be blurred while that happens. Although it might not be very conscious. Maybe even though you knew it was happening, you wouldn't quite be able to see that, but you will see the difference when it doesn't happen. It's more, never mind. I'll drag them back in and then show you just the blur that was going on. And again, thanks to D3's data step, I can adjust the amount of blur that each of these circles will get based on the underlying data, making the cheetah the most blurred one of all, and the tortoise basically doesn't get any blur. And this is not just for circles and these simple SVG elements. You can also apply it to images. I mean, this isn't totally my style typically, but if I move these outward, they have been blurred as well. So time for my favorite effect, the Gooey Filter. So I first saw this in a really good loading button demo made by Lucas Weber. And I kind of filed that in the back of my mind, like I want to apply that in some sort of data visualization at some point. Sometime later, I was making sort of a visualization for the Ladies Open, which is a golf tournament, where people could do a golf clinic and then we'd visualize the results. And there was one chart that showed you how far the ball had gotten. And I could show it like this, but that felt kind of boring. So I thought, well, maybe I can let it start from 0, because that's kind of what happens, which was better, but I wasn't feeling it yet. And that's when I remembered that Gooey Filter. And I thought, well, maybe that's something I can do. So with that change, it now seemed more like the ball was ejected from the start, as if it was trying to acknowledge the effort made by the participant. And it didn't make the visual any more true or false, but it just made it a little bit more fun to watch. I'm not even going to try and explain what happens in this filter because I only understand about half the steps. But besides this wonderful gooey effect, it also has some really nice color blending to boot. But a more proper data visualization. Maybe like if you want to plot the 150 largest cities in the world, you let them start from some center point and let them sort of blurb out. Or the other way around, because lots of these are in the same country, so we can make them group back on a country level, but when they come back, they form one country blob again. And while I was creating this, it reminded me of this other sort of demo that the creator of D3 once created. And I thought, well, I'll just make it. I mean, this is already fun to do. But then I add a little bit of goo, and it's even more fun, I find. It's like you're playing with mud or Play-Doh without getting filthy. It's kind of like that Spirograph idea, just having fun in the browser. So, time for my final filter. So this one, the idea is like that these wonderful color blending effects where two colors overlapping each other can create an entirely new color. And this one is not done with SVG filters anymore because I tried it at first, but I found out it can be done with just 2 lines of CSS. So even though this is not like an SVG filter anymore, the result is visible in SVG, so I kept it as the final example. And these are 2 of my favorite blend modes. And you can apply that by setting the mixed blend mode of these circles to either of them. But it is also very important that you group your circles and apply an isolation to them, because otherwise the background color will be taken into account when the blend modes are calculated, which means that for screen, if you forget, you will see this. You will see like nothing in your screen. There are no error messages in the console. Apparently your circles are somewhere in the DOM, but they're not showing up. And I mean, at this point when I was learning about blend modes, I wasn't into the web for very long, so I totally didn't know what was going on. I basically just wanted to give up. One of those times when you feel like it's really the computer this time and not me. But thankfully, some blog didn't mention this isolation property. The same would have happened if I was trying to experiment with multiply on a black background. But thankfully, yeah, isolation. So I use this in data visualization when I have cases of minor overlap. So here we have just a line chart with some average daily temperatures for 8 cities across a year. I just chose something that had a lot of overlap, and I made the lines extra thick. But why should Amsterdam always be plotted on top just because it was plotted later? I mean, all of these cities are equally important. And typically people try and work with opacities, but for one, I don't want these lines to be any less visible when they're not overlapping. And even with opacities, when something is sort of overlapping, you could still see that Amsterdam is on top. So instead, I apply a multiply blend. Besides making for a visually just a little bit more interesting result, if you look at the areas with some sort of overlap, you cannot see anymore which one lies on top of the other. I mean, it's kind of the idea of these blend modes, this one in particular. You can also use it for circles, but only if some part of the original circle is still visible. So here we have a completely random slope graph of animals. And we have an issue here where the purple giraffe is overplotting the red deer, which isn't fair. All the animals are equally important. So I apply the multiply blend mode. And now, again, with the benefit that you can no longer say which circle is on top of which circle, you get the extra benefit that you can see the total contour of both circles again. I mean, this starts breaking down if you have too much overlap, but with this sort of minor cases of overlap, I find this works really, really well. But I guess, to be honest, this particular thing, so the blending modes, I feel that works best with examples that are a little bit more data art or generative art based. So for my final example, just something that I can look at indefinitely, and it really, the blend modes really make for a difference because this is how it looks without them, so I definitely say that's less magic. So yeah, I hope that some of these examples that I've showed you, if you are into creating data visualization or something else that is very visual, will inspire you to someday kind of make it just a little bit different. But also I hope that you will be driven to sort of step outside of the box and try and think differently to make as few concessions to the computer as possible in your quest to recreate the image that you have in your mind. But I also hope that you'll go beyond the shapes. So, like I've mentioned a few times here and there, I've written a blog post around each of the 9 examples that I've written. You can find it on visualcinema.com/blog. You might have to go to the archive. I've written a few new blog posts since then, but you can find it under SVGs Beyond Mere Shapes. Also, DataViz lives on Twitter, so come join me there. And finally, thank you very much for your attention. Again early.
You were early.
I was early. I don't know what I missed, though.
It was wonderful. Well, I don't think you missed anything. That was just great.
Show us pretty visuals.
Yeah, just show us more pretty things. We can fill 10 minutes just standing here
Yeah, I can
looking
show you
at more.
some things.
Yeah, that's... Right, we've got some questions. That was wonderful, by the way.
Thanks.
We've got some questions from the interwebs. Most of these, we got 2 combined ones, I think, which is, are there any do's or don'ts to improve performance when dealing with SVG filters?
Ooh.
This sounds a bit more low level, perhaps.
Yeah, well, there are 3 things that are basically the bane of my professional existence. One is browser bugs, the other is screen sizes, and the last one is performance. So performance is always takes a lot of time. So specifically with SVG filters, I would apply it, if it is too much, apply it to where it makes the most difference. So maybe you don't have to do it to every circle, but maybe just a few ones to get the right effect that you're looking for. Or otherwise, what I do if performance is a real issue, I go to Canvas. And they have filters as well, such as the blur. However, I believe Safari is not handling Canvas filters as of yet, but at least some of the others are.
That's something you can just switch in D3, isn't it? You can switch it to Canvas rendering mode. Very cool.
Well, yes and no.
Vaguely, I'm not
So
really developing.
so yes, so D3 has functions, like for example, if you want to make, let me show you. So, so this one, these lines, they are kind of smoothed down at the tops and bottoms. It's because people actually prefer looking at smoothed lines instead of these very angular ones. And that's the thing that D3 does. It has a line function for you. So you say, D3, my line, I have this data, the X is in this position, the Y is in this position, and I want you to slightly smooth it according to this. And that's kind of just a name. There are like 10 different ways to smooth it, from very intense smoothing to like subtle smoothing. And that one you can say either do it SVG or do it on Canvas. So that one's pretty easy. But if you want to do it other than that, so not quite using D3's functions, but you just want to plot circles or maybe rectangles, you need to go into the Canvas API and do like ctx.beginPath or fill rect. So it's like a sometimes yes and sometimes no. The harder things D3 does for you, the easier things you have to do on your own.
Just like life, this is. Have you got any opinions on CSS filters? Strong or loose opinions?
No, well, they're good. I use them as well. I guess I use SVG filters a little bit more because that's where I came into the web through, and now I'm using Canvas. So again, then maybe these CSS filters don't really have that much of a difference. Well, at least using the filters, I want to use them on the elements themselves. I have used CSS filters, but I don't know why not more. I guess you have to make a choice.
That's something to explore, I think. Yeah. We've got another one here. I think this one's quite good. How do you deal with accessibility in your visualizations?
Oh, that's a tricky one.
Oh, that's a whole talk right there.
So It hasn't been solved yet. I mean, people in the community are still trying to figure out what is the best way to go about it. And what seems to be now is just kind of, so maybe usually charts, they can have like a main conclusion. Like this is what, the Apple stock has been rising, but after Steve Jobs left, it fell. I don't know. That you can make that into a title and then just skip the entire visualization. The visualization does give context, but you try maybe with some text, you try and capture the main content of the visualization. And then yes, there will be some subtle context that might be missed, but data visualization is in itself very visual, so that you can only capture so much.
There's sometimes when you can put the raw data on, you know, sometimes that's applicable.
Yes, but people are very bad at numbers. I mean, sorry, but how I say this, but even seeing a table, we cannot. It takes us minutes. If you show me this data in a table, it can take me an hour to figure out what's really going on. If I see this within a fraction of a second, I get a feeling for it. Within a few seconds, I can see that Svalbard is basically very cold and Dubai is really hot. So we are very visual beings to be able to understand data visually. If you hear data coming by, it's even worse than seeing data. It's like you're blabbing random numbers to a person. There's no use. So if 5 numbers okay, but this kind of numbers, it's just, you need to skip that.
I would definitely prefer to see this. I know this. This is much better. We've still got a bit of time, actually, so are you okay for more questions?
Yeah, sure.
Fantastic. Do you worry about different browsers rendering things differently?
Yes.
Great, next question.
No. The one thing is colors. Colors can be subtly different in different browsers, or like small things like line thickness. But also, like with the browser bugs, I was doing a project recently with, let me show you, with Houdini, but then in this one. Oh, I know the. Why am I doing it? So this one is a project, my latest project, and that uses Houdini. So for example, the background behind here is Houdini. The scratchy boxes over here is Houdini, because the visualizations that I made are also kind of like sketchy. So I wanted the content, the layout to be sketchy as well. However, if I open this up in Safari,
we have live browsing going on. Danger zone, danger zone.
Yes. So here I have some of the things going on with the polyfill, but other things like here and the scratching that I had, you can see the difference. I chose to use the polyfill for the most important ones, but the other ones I kept simpler. And I really hate it, like I said in my talk, I really hate it when I cannot make the browser do what I have in my mind. So it kind of me off, and then and then it takes so much more time to figure out, okay, so this browser does it differently. How am I going to deal with that? For example, the animated gradient, that in Safari, the reflect used to not work. So I had to make like, how am I going to deal with the reflect? So I made it like twice as big, and then you can move it halfway through it and then move it back again. These things just...
Man, who'd be a web developer? It's hard. Wow. But I think that says the importance of progressive enhancement there, about applying things as you can. We've got a very important question here. What data is visualized on your shirt?
I would say that there's like a line, there seems to be a pattern here of like 2 white, then 1 yellow, 2 whites, black, and then red limbs. So it's kind of like just lines.
That's important data. Just lines, right? Okay. And there's one here that I'm not sure is left over from the previous talk, or if this is an astronomy question, what is your opinion on Vega? Oh, no, that... Which is
that
a
could
star
be, maybe
and
that
a
could
library.
be both. Vega is one of these wrappers around D3. So it's instead of having to write out the JavaScript of D3, you basically give it sort of a JSON with the settings. So you say that I want to make a line chart, and X is this, Y is that. The lines should be colored according to this. So you're just giving in all the visual encodings, how it should go, and then Vega turns that into a D3-based visualization. So my opinion is that if you are not like, I am like, this is my thing, I am a freelancer in data visualization, so I want to work with D3 because It gives me the lowest level possible of working with SVGs or canvas in this way. I can make it exactly as I have in mind. Whereas in Vega, I can only make changes to the things that Vega has provided me access to. So if you want to make good visualizations, but you're not into it as much as I and my fellow database peers am, then Vega is great to use actually, because it can also do interaction. But if your heart is telling you that you want something different than what the tools can do for you, then it's time to go into D3 itself.
Okay, go low level. And because we've got a lot of accessibility people in the room, again, we've got one. How do you deal with colorblindness in data visualization?
Yes, so there, I have these apps, extensions over here somewhere. Oh, here we go, here it is. You have these extensions that you can sort of apply to and see how that would look. So there's also something you can do that has, is a color scale. There are some color scales that have been made not only to cycle through hues, but to cycle, sorry, not only to, yes, that's it. Cycle through hues, but also to cycle through luminosity. So this one goes from light to dark in a monotonous way. So if I were to do like if I were to print this, you would see a black to white gradient. So these are ways that you can deal with that. And sometimes you need to figure out, you can maybe use a darker green versus a lighter red. So it's kind of like testing it out and seeing when it is important. Maybe for this one, for example, it's actually not important to see what these colors are. They're just there for like a visual pleasantness. So then it doesn't matter.
Testing with real users. I think that's the only thing you can do. I think that's all the questions. I absolutely loved this talk. It was amazing.
Thanks.
So let's have a huge round of applause again.